In the lower part of the Mississippi River, there is at times an issue with salt water from the Gulf of Mexico making its way upstream. To combat this, a sill is built in the river and fresh water is sent by barge to drinking water treatment facilities along the river. This is done to try to get drinking water salinity levels down to acceptable levels. This intrusion of salt water can also impact crops that are irrigated using Mississippi River water. Let's examine why this occurs. The Mississippi River empties into the Gulf of Mexico. This is the source of the salt water that travels up the river. We can take a cross-section of the river near its end. The water elevation will be at or near sea level. However, the channel section lies well below sea level. In fact, the channel bottom doesn't reach sea level until we get about 350 miles upstream at Natchez, Mississippi. Because the channel is below sea level, this allows the denser salt water from the Gulf of Mexico to collect in the bottom of the channel, below the less dense fresh water in the river flow. If the flow coming from upstream is not large enough, the salt water will propagate upstream in a wedge shape. To combat this, a sill is built to try to push the saltwater wedge higher into the water column where higher water velocities are present in an attempt to slow the progression of the wedge. The sill, however, only slows the progression of the saltwater wedge. It doesn't stop it. The sill is built about 60 miles upstream of the Gulf of Mexico near Myrtle Grove, Louisiana. This is about 40 miles downstream of New Orleans. The sill has been constructed 5 times since 1988. The sill is constructed about once per decade. However, it has been constructed in the consecutive years of 2022 and 2023. In 1988, the saltwater wedge worked its way up to New Orleans and beyond, ultimately reaching the city of Kenner, Louisiana. Flows of approximately 300,000 cubic feet per second are needed to prevent the saltwater intrusion. The degree to which saltwater will progress upstream is dependent on several factors, the most important being the amount of time that the river flow is below 300,000 CFS and how far the river flow is below 300,000 CFS. These are Mississippi River flows from 2022. Eventually, higher flows occurred in 2022 that pushed the saltwater wedge downstream and eroded the sill. Thanks for watching this video. There's more water resources engineering videos on the way.